Imagine feeding an entire region for over 2,000 years without electricity, pumps, or massive dams. That's Dujiangyan, the ancient Chinese irrigation system still powering farms today through gravity alone. In our fast-paced world where food shortages hit headlines and climate shifts disrupt harvests, this forgotten gem reveals how working with nature beats fighting it. It's not just history, it's a blueprint for resilience. Think about your own life, struggling with water waste in your garden, facing higher food costs. Dujiangyan's principles, like channeling flows naturally and minimizing inputs, can inspire simple tweaks. Start by assessing your local water sources and building small diversions to reduce reliance on utilities. It's actionable. Test it on a small scale, track results, and scale up for better yields with less effort. This connects us all. Our ancestors solved these problems sustainably, and so can we, fostering hope amid uncertainty. Before we continue, kindly tap the subscribe button on your screen to uncover more lost food secrets on the Lost Food Archive. Now, let's explore how it began. Nestled at the transition between the towering Qinghai Tibet Plateau and the fertile Sichuan Basin, Dujiangyan emerged as a pioneering solution to harness the Min River's volatile flows. Originating in Sichuan Province, China, this system was engineered for precise diversion and distribution of river water to support irrigation across expansive farmlands. Its design proved exceptionally effective in mountainous river settings marked by intense seasonal floods, where steep gradients and sediment-laden waters posed ongoing challenges. By leveraging the natural topography, such as the river's bend and elevation drops, the system channeled water without impeding the main flow, ensuring stability in an environment prone to extremes. Geographically, Dujiangyan centers on the Min River Valley, just northwest of Chengdu, at the western edge of the Chengdu Plain. This location, where the river descends from high mountains into lowland plains, created ideal conditions for controlled water management, transforming flood risks into agricultural assets. Constructed around 256 BCE during the Warring States period under the direction of Li Bing, governor of Shu, and completed with input from his son, the system has operated continuously for over 2,200 years. This enduring timeline spans from the Qin dynasty through successive eras, adapting through modifications while retaining its core principles. At its heart, Dujiangyan addressed the dual threats of devastating floods and water scarcity in the region. It solved the core problem of managing unpredictable flooding by splitting the river into inner and outer channels, providing reliable irrigation to parched plains without blocking the waterway, thus preventing silt buildup and enabling year-round usability. This foundational setup grounded communities in a balanced interaction with their environment, setting the stage for sustained productivity. Now, on to its functional advantages. Compared to modern dam and reservoir systems, Dujiangyan required less construction material and energy input, tolerated heavy sediment loads, and functioned reliably under extreme seasonal flow variations. Yield behavior. It enabled stable irrigation across over 667,000 hectares, supporting consistent multi-crop production on the Chengdu Plain by delivering water evenly without large storage losses or evaporation. Labor requirements. It depended on annual manual sediment clearing and minor repairs during dry seasons, avoiding the need for constant mechanical intervention or large operational teams. Input needs. It used zero external energy, relying solely on the river's natural gradient and topography for diversion and distribution. Resilience factors. Its design automatically separated excess floodwater and sediment via the fish mouth levee and flying sand weir, flushing debris downstream while maintaining intake flow, reducing blockage risks that plague gated dams and pumped networks. This self-regulating mechanism minimized single-point failures and adapted to natural variability without power or complex controls. Modern irrigation systems are often designed around control and scale. Large dams restrain rivers behind concrete walls, storing water for later release and generating power in the process. These structures can move vast volumes of water and support industrial agriculture, but they do so by centralizing control and imposing rigidity on natural systems. Their effectiveness depends on constant oversight, mechanical components, and uninterrupted energy supply. When those supports fail, the system itself becomes vulnerable. Dujiangyan reflects a different set of priorities. It does not seek to dominate the river or halt its movement. Instead, it preserves flow and redistributes it. Where modern dams concentrate water and authority in a single structure, Dujiangyan spreads risk across multiple elements. Balance replaces control, guidance replaces resistance. The system's intelligence is structural rather than mechanical, embedded in shape, slope, and placement rather than in machines. This contrast reveals a deeper trade-off. Modern systems trade energy for flexibility, electricity substitutes for terrain, pumps replace gravity, and active management compensates for environmental variability. Dujiangyan, by contrast, embeds intelligence into the landscape itself. Once built, it requires no external power. The river supplies its own energy, and the system responds automatically to seasonal change. As agriculture modernized, this shift in approach had consequences. Infrastructure began to be built for decades rather than centuries. Systems optimized for rapid deployment and high output often sacrificed durability and adaptability. Centralized control replaced local stewardship, distancing communities from the systems that sustained them. Maintenance became specialized, intermittent, and reactive instead of continuous and communal. Efficiency increased, but resilience declined. When systems are optimized for uniform conditions, they become fragile under disruption. Droughts, floods, energy shortages, or political instability can interrupt water flow entirely. What was gained in scale was often lost in stability. Dujiangyan remains relevant because it represents an alternative path, one that still functions in the present tense. The system continues to irrigate millions of hectares across the Chengdu Plain, supporting one of China's most productive agricultural regions. It has never required a fundamental redesign. Instead, it has been adjusted, repaired, and maintained in continuity with its original principles. Engineers and hydrologists around the world study Dujiangyan not because it is ancient, but because it is effective. Its relevance has increased under conditions of climate instability, where floods are intensifying, rainfall patterns are shifting, and energy reliability cannot always be assumed. In such contexts, systems that function without external power are not historical curiosities. They are strategic assets. The lesson of Dujiangyan is not that ancient societies were more advanced because they lacked modern technology. It is that advancement was defined differently. Dujiangyan was sophisticated because it understood limits of rivers, of materials, and of human control. Longevity was not a byproduct of its design, it was the goal. In a world increasingly shaped by short planning horizons, Dujiangyan stands as evidence that infrastructure can be built to endure when balance, adaptability, and restraint are treated as strengths rather than constraints. Dujiangyan is only one example of how ancient societies solved scarcity by working with natural forces instead of overpowering them. In the next episode, we'll examine another system that approached the same problem from the opposite direction, using control rather than balance, and explore what that choice reveals about how food systems evolve over time. If you want to continue this investigation into the forgotten infrastructure that sustained civilizations for centuries, subscribe to The Lost Food Archive. Each episode uncovers a system that shaped human survival and still has something to teach us today.